This video is a review for the lesson on Ingenuity, multiplying and dividing rational expressions. So to start off, I just wanted to show you what I call my factoring flowchart. If you feel free to go ahead and take a picture of it right now on your screen. If it's blurry, let me know. I would be happy to post this in Schoology or take a picture and email it to you individually if you want. So basically what this is if you're stuck on a problem that you're trying to factor, this kind of helps you work it out. So what you should always start with is ask yourself this question: can I divide out a common term? Meaning, is there something that I can divide out of all three numbers? So looking here at my three terms here, all of the numbers in front are divisible by 2, so I can divide that out. They also have at least one x on there. This one has 3 of them, this one has 2, and this one has 1. As long as they all have at least 1, you can divide that out. So when I divide out a 2x, factor out a 2x, it's essentially dividing. So if I take 2x cubed and I take 2 x's out, that leaves me with an x squared. 4 divided by 2 is 2. I had an x squared and I just took 1 off, so it's still just a plain x there. And 10x divided by 2x, 10 divided by 2 is 5, and we took its only x off. So that's what you should look for first, is dividing out a common term. After you do that, you need to ask yourself how many terms are there. And when I say that, ignore this thing in the front. I just mean the part that's left. Or if you didn't factor anything out, how many terms are there. So this one would be an example of 3. But looking at all of them, if you have 2 terms, what you need to do is look for a difference of squares. Difference means subtraction. So if there's ever a plus sign in the middle, you can't do it. So like here, 4x squared minus 25, that's 2x squared minus 5 squared, and so it'll factor into 2x plus 5 and 2x minus 5. And then what you should do for 3, you need to ask yourself, is there a number in front of x? If there's not, great, multiplies 2, adds 2. If there is, then you have to do the AC method. And then if there are 4 terms, you need to do factor by break it in half. Divide something out of the front, divide something out of the back, and these 2 things have to match. Again, if you want me to send you a picture of this, I'd be happy to. It might make more sense after I do a few examples. Now remember, this is just for you, so if you think you need to watch all the examples, if you just want to pick and choose a couple, it's totally up to you. So the first one we're multiplying here, it's just a bunch of monomials, meaning nothing is being added or subtracted. So when you multiply fractions, you just go straight across. So looking at the numerator, first we multiply the numbers. 5 times 6 is 30. And then we multiply the x's, so 2 separate bases. So x squared times x cubed means you add them. So that means we have x to the 5th in the numerator, and a y times y squared, that means there's 3 of them up there, so that's y cubed. Over in the denominators, multiply the numbers first. 2 times 10 is 20. Then it looks like we only have that singular x right here, so I'm going to put that next. And then y cubed times y, that remember you add the exponents when there's 2 separate bases, so 3 plus 1 is 4. Now we're not done until we have simplified the numbers, and then also there can only be 1 x in the whole thing and 1 y in the whole thing. So just looking here, 30/20ths, that's going to simplify to 3/2 because they're both divisible by 10. Remember, when you have exponents on top and bottom of a fraction, you just subtract the smaller exponent from the bigger. So right here between 5 and 1, what number is smaller? 1. So I'm going to take that away from the 5. So that numerator becomes x to the 4th. Here, what's smaller, 4 or 3? 3 is smaller. So I'm going to take it away from the 4. So that's y to the 1st power, or just y. Now, if you're multiplying and you have things that are being added or subtracted, the first thing you have to do is factor. Factor everything that you can, and then simplify from there. So like right now, the way this looks right now, a lot of people are like, oh, well, I'll just cancel out those x squareds. You can't do that. You can't cancel out things that have other things being added or subtracted onto it. Only when things are multiplied can you cancel. So here in the numerator, out of 4x squared and minus 4x, I can factor out the common term 4x. So 4 divided by 4 is 1. If I have an x squared and I took one of those x's out, I only have 1 minus 4x divided by itself is just 1. Okay, so now let's look at the denominator. Nothing I can divide out of all three. There are 3 terms, and there's no number in front of the x squared. Besides, there's an imaginary 1 there, but nothing is written. So when that happens, you decide, okay, what multiplies to -3? What two numbers multiply to make -3, but when I add them, I get +2? 3 times -1 is -3, and 3 plus -1 is 2. So that means this denominator factors into x plus 3 and x minus 1. Okay, now let's look at the second one. Again, 3 terms, nothing in front of the x squared. So what multiplies to -6 and adds to 1? Multiplies to -6 and adds to 1. So this will factor into x plus 3 and x with a -2. Just like we did on this last one up here, when you multiply, go straight across. So I'm just going to write everything on one big fraction. So 4x, x minus 1, x plus 3, x minus 2, all over. Anytime I have a monomial like that, so this 4x has nothing being added or subtracted, I tend to write that in the front. And then other than that, it doesn't matter. Okay, so now you might be thinking, well, wait, she still has things that are added and subtracted. Yes, but all of these parts are being multiplied. So if you can factor out a whole, cancel out a whole part, you can do that because they're all being multiplied. So for example, we have a 4x in the top and bottom, cancel. I have an x minus 1 on top and bottom, cancel. I have x plus 3 on top and bottom, cancel. So if you notice, all we have left in the numerator is x minus 2. When everything cancels out, it's just there's a 1 there. Well, an x minus 2 divided by 1 is just x minus 2 is how that is multiplied. Okay, so I have 2 more. Remember, you don't have to watch, but it might be a good idea if you're struggling. So when you divide these rational expressions, you're doing the same thing essentially as multiplying, just multiplying by the reciprocal. So a lot of you, when you divide fractions, you've heard the term keep, change, flip. That's the same thing as multiplying by the reciprocal. So we're going to keep this the way it is. I'm going to go 5x over, meaning the orientation. I'm not going to flip it. But as I go, I'm going to go ahead and, actually, no, I'll wait. Just kidding. Change division to multiplication and flip or use the reciprocal here. So now x squared minus 6x plus 8 is on the top, and x squared minus 2x is in the denominator. So then, like I said, before you multiply, we're going to factor everything that factors. So on this denominator, both of these values are divisible by 3, so I'm going to divide that out. 3x divided by 3 is x, minus 12 divided by 3 is 4. 3 terms here with no number in front, so we have to decide what multiplies to 8 and adds to -6. Multiplies to 8, adds to -6. So x with a -4, x with a -2. And in the denominator, both of these values are divisible by x, because there's only 2 of them there. And then we're left with x squared divided by x is x, minus 2x divided by x is just 2. So when we multiply straight across, remember, if I'm going too fast, you can always pause. Here I have another one of those monomials, just an x by itself, so I'm going to put it after the 3. So I'm going to go 3x, x minus 4, x minus 2. Okay, so if we have the same factors on top and bottom, they can cancel out because everything here is being multiplied. 3 times x minus 4 times x minus 2. So we have x minus 4s on top and bottom, x minus 2s on top and bottom, and we actually have plain old x's on top and bottom. And so all that we're left with here is 5/3. All right, last one. So x, I'm going to put this in parentheses so that we remember that x plus 5 is glued together. The only way you can get rid of anything is if you cancel out the whole x plus 5. I'm going to write this as a fraction to help us out, so just over 1. Oh, and here we have division, so keep, change, flip. Okay, so before I write down what this is, this part here can be factored. So there's nothing that we can divide out of 9 and 25. Those are stuck. So we're left with 2 terms. So if I go to the 2 terms box, we're going to look for a difference of squares. Is this something squared minus something squared? It is. 3x squared is 9x squared, and 5 squared is 25. So this will factor into 3x plus 5 and 3x minus 5. So I put them all together. Remember that x plus 5, these are glued together, unless you can cancel them out completely. Multiplying by 1 doesn't change anything, so that's why I didn't write it down. Okay, so it looks like we have an x plus 5 on top and bottom. We have a 3x minus 5 on top and bottom. So we're left with x over 3x plus 5. And as a reminder, these x's cannot cancel out because this one has a plus 5 attached. Anything added or subtracted, you have to cancel out the whole thing or else it's stuck.